So day 79, EOC review, bell ringer. So this is our next one in our EOC review. What is the slope of the line graphed here? So we're going to count our rise over run. Rise over run is our slope. So we're going to find good intersections where we're crossing perfectly over the vertical and horizontal lines of the coordinate plane. And we're going to count up and over, up and over, up and over. And you do want to do at least 2 to 3 to get a really solid answer. So it looks like we rose 1, ran 2, rose 1, ran 2. So rose 1 or rise 1, run 2. This line is increasing. So as x increases, our y values also increase. So that means this line is a positive line. So that 1 over 2 is our slope for this line, just like that. And I always just check to do positive and negative after the fact to double check and make sure I don't make a mistake, because that's the way my brain messes up, is I don't always recognize the negative line when it's time to just pull the slope. All right, in which graph does the shaded region represent the solution set for the inequality shown below? So things to think about. We know this has to be a dashed line because there is no equal to. So we know it's a dashed line. All 4 of them are dashed lines, so that's not going to help us. We want to put it in slope-intercept form, so y equals mx plus b form. So I'm going to move that 2x, and I'm going to write it over here. 2x minus y is less than 4. So we're going to move the 2x because I want y by itself this time, because I want it in y equals mx plus b form. So that 2x to move to the other side, we're still crossing the great divide as we always discussed in our regular equations. So we're going to do the inverse. So I'm going to subtract because that's the opposite of that positive 2x. So I end up with a negative y is less than 4 minus 2x, because 4 and 2x are not like terms, so you don't want to combine those. We're just getting it, we're switching seats. We're moving into different rooms. Now, big call out. So right here, that's a negative 1 in front of there. To get rid of that, we are going to divide by a negative 1. So this is the golden rule of inequalities. If divide or multiply by a negative, must flip the sign. This is where most of you are going to mess up, because it's not a super hard equation to solve. But if you forget the golden rule of inequalities, when we divide by that negative 1, right there, you should hear ding, 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 ding going off in your head. It's going to be y, and instead of less than, it becomes greater than. Positive 4 divided by negative 1 is going to give me a negative 4 as my starting point. Negative 2, negative 1 is going to give me a positive 2x. So my b value, starting point, is going to be negative 4. My m, or my slope, is going to be 2. I am going to now shade up because this has now become a greater than. And remember, that is all relative to the y-axis. So looking at this portion of the y-axis. This has a positive 4 for our starting point. So those two are gone just because we know that that positive 4 is not the starting point anymore. These are probably getting you from the positive 4 here. You might have tripped up there if you were just looking there and didn't put it in slope-intercept form. And then we have negative lines, which our slope in this case is positive. But again, if you didn't move everything around, that might be y, because these are decreasing. So as x increases, the y values decrease. So these are decreasing. A and B are no good. So now we're between C and D. So again, it's a greater than, so it should be these numbers, whereas D has, it looks like, whoops, I'm drawing it the wrong way. D is shaded this way. That's where our shading is. Versus our C one, it looks like it's actually shaded down. So disregard that down area that I drew on the other one. I was getting excited. So our shading up is for D. You don't see the y-intercept because it sort of happens down here at that negative 4 for both of these. It is a dashed line, so D is our solid answer for that guy. All right, the length of a rectangle. First thing you should do, draw a rectangle. The length of a rectangle is, and then I have width and I have length, because we can go ahead and imagine it's going to say area. So length to area is length times width of a rectangle and a square if you want to memorize one formula. So the length of the rectangle is 15 greater than its width. So it's going to be width plus 15. If each is decreased is subtraction, by 2. So I'm going to do minus 2 minus 2, the area will be decreased by 106. So minus 106. And I just write the area inside the rectangle so I know that's where area is. But we have to know what the area was before we made the change. And that's at W plus 15 and W. So W times W plus 15. If this is calculator active, you could leave it this way and go to Desmos. Just make sure you use X instead of W. But let's see if we can do it long way because we're going to get better with quadratics. So we distributed the W squared plus 15W, which is our area. And then we subtract 106. Now, we can clean this guy up because these are like terms. So it's going to be W plus 13. So area, we're going to do W plus 13 times W minus 2 equals W squared plus 15W minus 106. Lots of ugly numbers, but hang in there. We can do this. Box method or FOIL is fine. So W13, W negative 2. W times W is W squared. W times a negative 2 is a negative 2W. 13 times W is 13W, and then negative 26 because 13 times a negative 2. Combine our like terms in the middle. It's going to be W squared plus 11W minus 26 equals W squared plus 15W minus 106. Now, we see W squared, so we know we want to get everything to one side so we can solve it, because ultimately we need to know what the value of W is. So I'm going to subtract and go to the left just out of habit. So minus W squared minus W squared. This goes away. These went away. Well, that's convenient. I'm going to move my 15 because we're trying to get everything to one side. So minus 15W, which is going to give me a negative 4W. And then I'm going to add 106. Add 106 because, again, we're crossing that great divide is why we're doing the opposite to move it. And I'm moving everything to the left. So 106 plus a negative 26 is the same as subtracting. And that's going to give me a positive 80 equals 0. This is a linear function, so now we just need to solve for W. So our stinky kid, we're going to now move that 80 across. And that's going to be a negative 4W equals a positive 80. Oh, sorry, negative 80 minus 80. Ooh, about made a boo-boo because it's the inverse of addition because it's crossing into the other room. 4W, that negative 4W is multiplication. So we're going to divide by negative 4. And W is going to give me a positive 20 because negative 80 divided by negative 4 is a positive 20. So our original dimensions, we're going to have a W is 20. So our original one, our width is 20. And our length in the original was width plus 15. So our length is going to be that 20 plus 13, which is 35. And that's for our original rectangle. Is 20 by 35. All right, two more. Hang in there. Frankie and Arthur are both saving money for their vacation. The table below shows the models for the amount of money Frank and Arthur, he lost a Y, Frankie and Arthur saved over X weeks. Now, you can graph these because basically we're looking for when they have the same output, like the solution to the system. It just doesn't say system. But if you put them in your Desmos, you're looking for when they intersect. But because f of x and a of x is the same thing as y, you could quite easily also set them equal to each other because they are the same. Y is and y is. So that means they are the same as each other. Then we're going to get our x's to one side. I'm going to work towards my positive x, which is going to give me 10 equals 2x plus 2. I want to solve for x. So I'm going to subtract 2 from both sides. That's going to give me 8 equals 2x. That 2x is 2 times x. So we're going to divide by 2. And x equals 4. So how many weeks? X is our time. Y is our money. So it's going to be 4 weeks. Now, how much money would they both have at that point? You're going to plug back in. Or the y value when you go and graph it, so of the coordinate where they intersect. So 6 times 4 is 24, plus 10 is going to give us $34. And then 8 times 4 plus 2 gives us 32 plus 2, which also gives us $34. So the coordinate would be 4, 32. And that means in 4 weeks, they would both have $32 in their account. Last but not least, so function notation reminder. We subbed in a 3 for the x, because remember, this is f of x. Sorry, my words are getting all tied up. F of x. So we put a 3 in the place of x. So when it says find f of 3, that means plug a 3 in the place of x. So 22 minus 3 in the place of x equals what? Is all that is stating. This is asking when x is 3. So when x is 3, what is our output, or y value? Is what the f of 3 means. So negative 3 times 3 is going to give me a negative 9. So 22 minus 9 is going to give me 13. So f of 3 equals 13. And again, that means when x is 3, y will be 13. F of x equals 10. So we're going to do the same thing, except we didn't plug it in the place of x. Remember, f of x is y. So this is saying y is 10. So if y is 10, what is x going to be? So I'm going to take y is 10 equals 22 minus 3x, because we just plugged it in the place of f of x. And now we're going to solve for x. We need to move whatever's on the outside of our box first. So minus 22 gives me a negative 12 equals a negative 3x. Negative 3x is negative 3 times x. So we're going to divide by negative 3, divide by negative 3, and we're going to end up with x equals 4. So then that means f of x, when it is 10, that would be f of 4 equals 10. So when y is 10, x is 4, and that would be written as a coordinate as such, and 13 as the coordinate for the previous. Great job, guys.